Okay, my screen is visible, right?
Yes.
Okay, so this is the first problem of today's Atcoder contest, and in this problem, we are given that we have two integers a and b, and we have to find the value of a to the power b plus b to the power a. So now the only thing is that a and b are very low. Like these values are very low. They are only between 2 and 9. So we can just use a brute force method, right? So we can just first compute what a to the power b is by simple while loop, and then calculate what b to the power a is, and then just find the sum of these two. So there is nothing else in this problem. So let me show you the implementation. So this is the implementation. In this, I'm first taking a, b as input, then I'm calculating a to the power b, and then I'm calculating b to the power a. Finally, I'm printing the sum. So I hope this is clear to everyone, right?
Yes.
Okay, so let's go to the next problem. So this is the next problem. In this problem, we are given that we have a string S, and we have to find the maximal length of contiguous substring of S that is a palindrome. Now, okay, so now in this problem also, as we can see that the length of the string is between 2 to 100. So we can again simply brute force our solution. So if n is like less than or equals to 100, how many, first of all, how many substrings there are in a string of length n? Maximum. What is the upper bound of one number of substrings? It's close to n square, right?
Yes.
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 Okay, actually it is like something like n into n plus 1 by 2. Like if you look at this is the total number of substrings that you'll have in a string of length n. So the upper bound is n square. So what we can do, if we have n square substring, we can check them each individually. So let's say, let's multiply this by again n. That is the length. Like assuming, like what is the upper bound for the length of the substring? It is n, right? You cannot have a substring of size more than n in a string of size n. So our total complexity will be n cube. So for each of the n square substrings, we can simply check whether or not it's a palindrome or not. If it is a palindrome, then we can check what is the size of it. And if the size is more than our current answer, then we'll increase our answer by 1. Like we'll update our answer. So is this thing clear? Like, can I show you the implementation? Is anyone having any doubt in this?
Clear.
Okay. So this is the implementation. In this, the answer 1 is always possible because if your string is having at least one character, substring of size 1 is always a palindrome. So that's why initially I'm initializing my answer as 1. Then for each of these substring, that is my I will go from 0 to n and my j will go from I plus 1 to n. So currently I'm looking at the substring which is from I to j. So I'm checking whether or not it is a palindrome or not. So how to check whether it's a palindrome? Just start your my I starting from L, that is this left boundary, j starting from R. And while I is less than j, I'm checking if at any position these two characters are not same, I'll return false. Otherwise, after once this loop gets terminated, I'll return true. So this means that my substring from L to R is a palindrome. So if this is a palindrome, I can take my answer to be maximum of answer or the number of characters in the current substring from L, I to J. So what is it? It is J minus I plus 1. Finally, I can print my answer. Is it clear?
Yes.
Okay, so let's go to the third problem. So in third problem, we are given that there's a slot machine with 3 reels, and the arrangement of symbols on the ith reel is represented by the string SI, where SI is.
Can you repeat the second question? Actually, I was disconnected, so I was not able to. So can
What
you
is your
repeat
doubt?
it?
What is your doubt in that problem?
No, actually, it's my
Okay.
internet issues, so I was not able to.
So we just have to since n is only up till 100, just iterate through all these substring. There are at max n square, like the upper bound for the number of substrings is n square, and just check each and every substring. So your total complexity will be n cube.
So what you wrote here, like auto is palindrome.
Okay, forget about this. This is just a function. You don't have to actually copy the same. You can write this. This is just a palindrome. Like you can write this as Boolean is palindrome, and you can do something like this. Is it? Like, this is the function, right? So this is inside main, and you'll have your this function here. Is it clear now? Like this will be int main. Is it okay? Yes, no, anything?
Yes.
Oh, you like if you want, I can explain this completely again. If you like, if you didn't understand.
Can you?
Okay, I'll explain this again. See, n is only up till 100, right? N is less than or equals to 100, right? Yes, no. Okay, so now how many total number of substrings there are possible? What is the upper bound? It's n square, right? So we can check for each and every substring whether or not it's a palindrome. So what is the number of characters, maximum number of characters that can be present in a substring? It's n, right? So there are n square substrings, and we are checking for each and every substring whether or not it's a palindrome. So this is the total number of operations that we'll be doing. And if in case you find that the current substring from L to R is a palindrome, you can take your answer to be maximum of answer or R minus L plus 1. That is the length of current substring. Is it clear? Yes, no, anything?
Yes, yes.
Okay, so this is what I have done here. So first I'm taking string s as input, then I'm initializing my answer as 1, then I'm iterating through each and every substring, and I'm checking whether or not it's a palindrome. If it is a palindrome, I'm taking my answer to be maximum of answer, comma j minus I plus 1. So now this is clear to everyone, right? Yes, no?
Yes.
Okay. So let's go to the next problem. So in this problem, we are given that there is a slot machine with 3 reels, and the arrangement of the symbols on the ith reel is represented by a string si. Now here si is a string of length m consisting of digits, and each reel has a corresponding button. So now if at t seconds you can press a button, like you can choose and press one button or do nothing, like at the th second. So if you decided that you're going to press a button corresponding to the ith reel, that reel is going to show you this character, that is t mod m, that is the number of characters that are written on each reel, t mod m plus 1th character. So we just want to find what is the minimum possible number of seconds from the start of the spin until all the reels are stopped, so that this goal is achieved. So first of all, how many people were able to solve this problem? Just write a quick yes, no.
No, I was
Okay.
not able to solve.
Okay, so let's suppose there are 6 characters written in the first, like 6 digits on the first reel. 1, 3, 2, 7, 6, 8. So if you stop after 2 seconds, what do you think? Which character? If you stop this after 2 seconds, which character will this reel show? It will show 2, right? If you stop after 0 second, you'll see 1. So this is how you're given 3. Assume that you're given 3 strings, and the length of each of these is up till m, and m is less than 100. M is less than or equals to 100. So we can just brute force our C. Our I will go for this string from 0 to m, our j will go from 0 to m, and our k will also go from 0 to m. So now I'm assuming that I will stop this string at I will stop this string at j, and like this reel at j, and I will stop this reel at k. Okay. Now if I is equals to j or like if any of these are equal, then I'll simply continue, because I cannot press to like during a second, I cannot press stop for 2 reels, right? Corresponding to 2 reels. So that's why I shouldn't be equals to j shouldn't be equals to k, and I shouldn't be equals to k. Like none of these should be equal. Now, if none of
And
these are
I, AK all will start from 0.
Yes,
right?
yes. Everything will start from 0. And if Si is equals to Sj and this is equals to Sk, like all of these are equal, then my answer is minimum of answer, comma, maximum of ijk. Like I'm stopping at either ijk. Is this thing clear? Yes, no, anything? And finally,
No, can you repeat it again?
which part is not clear?
These equal and
No,
maximum. Why are you taking maximum of
Okay,
ij?
maximum of these. Because see, we have to find what, like I'll show you the problem statement. We have to find the minimum possible time from start of the spin until all the reels. So all the reels are stopped. So that's why we are stopping our first reel at I second. We are stopping our second reel at J second, and we are stopping our third reel at K second. So after maximum of all of these three, all the three reels would have been stopped, right?
Yes.
And out of all of these possibilities, we have to pick that answer which is minimum. So that's why answer is minimum of answer,
hello.
comma. Yes.
Suppose all the values, suppose it is 1, is present in the 0th index, then the answer should be available. But here we are not getting any answer,
Why?
no?
No. How is answer possible? Like you cannot press
Because
corresponding.
first
Okay,
I'll
let me
stop
speak.
at
Let me
0
speak.
second, then after that 0 plus m second, then after that 0 plus 2m second.
You are talking about this test case, right? You're talking about which test case? This test case.
Yes.
Okay, like you're
Yes.
talking about my solution. Okay, I haven't completed my. Okay, you are talking about my solution. I haven't completed, but I'm just asking you whether till this point is it clear? Like, okay, you are talking about my solution, that if in case we have something like this, then our solution, you are saying that we won't get our solution if we follow this thing, right?
Yes.
Okay. It's okay. Like I thought you were talking about that test case. I have not completed here. I'm not like completed with this approach. But is everything clear till this point?
Yes.
Yes.
Okay. So now coming to C. Now what? Okay, let's talk about this case. So what is this case when you have at ith place only you have same characters? So if at ith time you take this thing, if you choose that you're going to stop at this point at ith, like you're going to stop your first reel at ith second, then you cannot press this button, but you can press this at I plus m, right? And you can press this at I plus 2m. So, and if like, so basically what we can do, if we have a string s, like we have our first string, first reel as this, we can consider our first reel to be, like we can add this string 3 times. We can consider our string to be this. Then if we follow this approach, our solution will always work. Why? Because now we are having, if we were having 0 earlier once, now we'll have 0 3 times. And we want every digit only 3 times. Like what is the maximum number of times that we'll want a digit in our string? At max 3 times. Because if it is more than 3 times, then it doesn't make sense. If it is 4 times, see, why I want this digit to be 3 times at least? Because if this, if at this point some other reel was selected, I cannot select this. If at this point some other reel was selected, I again cannot stop this reel. But it's not possible that at this point also I'm selecting another reel. Why? Because there are at max 3 reels. So other than this, I can select only 2 other reels. So a digit like these can be like, I cannot select these at max 2 times, this 0 digit, but I can always select this 0 the third time. So are you getting my point? Instead of taking string as like 3 strings as it is, let's say these were the 3 strings that I have in input. Instead of taking these as it is in input, I will just take string s 3, like string s of 0 is this thing now. This was string s of 0 initially. I'm taking it 3 times. Is it making sense? And similarly here also, s1, s2. So this is s1. So I will modify my input like this, and then I'll follow the same approach, I, j, k. At I will stop the first reel. At j, I'll stop the second reel. At k, I will stop the third reel. Now, if I is not equals to j and j is not equals to k, and s of I is equals to s of j equals to s of k, then my answer is minimum of like I said, answer is minimum of answer, comma, maximum of I, comma, j, comma, k. And now one more thing. My I, j, k will now go from, can anyone tell me? From where to where my I, j, k and will go? Like initially I was
0 to 3m.
Yes, from 0
0
to
to 3.
I will go from 0 to 3m. J will also go same and k will also go same. Is it clear now?
Yes.
Yes. What about others? Is it clear? Or is anyone having any doubt? Okay, I'm receiving some place in the chat. Okay, no one is having any doubt in this, right? I'll show you the implementation. So this is the implementation. First, I'm taking M as input. Then I'm taking all the 3 strings as input. Then, like I said, for all the 3 strings, I will update them. This is nothing but like you can write this like this also. So I'll update the string, all the 3 strings as, like I'll take them 3 times. I'll concatenate them. Then initially my answer is 1 in 9. Like it is definitely this value is more than 3m. So if my final answer is more than 3m, then I'll definitely know that my answer is -1. So I'll print -1 only. Then what I'm doing, my I is going from 0 to 3m, my j is going from 0 to 3m, my k is going from 0 to 3m. If in case I is equals to j or j is equals to k or I is equals to k, I'll simply continue. Otherwise, what I'll do, if like if in case this is like these two are not same, these two are not same, or these two are not same, I'll simply continue. Why? Because I also want all the 3 reels to show the same digit. Okay, I don't think like I needed it to do like this. I can, this will also work. Because if these two are equal and these two are equal, it means that these two are also equal. Right? So anyway, after this point, I will take my answer as to be minimum of answer, comma, maximum of these 3 values. Finally, I can print my answer. Is it clear?
Yes, clear. The max function it works like this. Like, can be like, is it from the template or we can do like that?
No, you can do it like this. This is like I have not implemented this. This is the inbuilt max function.
Okay. Like I was always take 2 values and
Yeah,
then
you can
max
do
of
it like this also. Yeah. Like
Okay.
this also works, but the bit like you can do like this also, or otherwise you can write it in curly brackets.
Okay.
Can you explain complexity of this approach?
It is 3m cube.
So this problem will also work for hard version, right?
No. How will it, like it is 3m, 3 here is n. So the complexity for that will be nm to the power n. And n in this problem is 3. So that's why n in this problem is 3. So 3m cube, and m is less than or equals to 100. So that's why it's working. In that hard case, m is 10 to the power, I think 5, and n is 10 to the power 2. So this won't work there. Like this is the time complexity, right?
Okay, got it.
So in this problem, n is fixed to be 3. So that's why it's 3m cube. Okay. So this is clear to everyone, right? Yes, no, anything?
Yes.
Okay, so let's go to the next problem. Okay, it's like that doubt is clear, right? If like someone was asking me if we have 0, 0, 0 in the first place.
Yes, I got it.
Okay. So let's go to the next problem. How many people were able to solve this problem during the contest, this 4th problem? Just write quick yes, no in the chat. Or you can unmute yourself and let me know.
Yes, it is a graph question, DFS.
Yes. So in this problem, we are given that there are n people numbered from 1 to n on a coordinate plane. So we only know that the position of the first person is 0, 0. That is he or she is at origin. And then we are given m pieces of information that from AI's person's perspective, person BI is XI unit away, like he's XI units away in X direction and YI units away in positive Y direction. So we have to find the coordinate of each and every person. And if we are not able to determine the coordinate of a person uniquely, then we need to report it as undefined. So first of all, since see what we are given, that person 1 is at 0, 0. This is the origin. Let's say he's here, he or she's here. Now we'll be given like, okay, from the second person, from first person's perspective, second person is here. From third person's perspective, second person is here. And maybe from fourth person's perspective, let's say fifth person is here. So, and from fifth person's perspective, sixth person is here. From sixth person's perspective, fourth is here. So how to solve this problem? See, since we only know that this person is here, this first person is here, why not start our DFS from this point, and we'll try to go like, just assume this to be a vertex and go to each and every neighboring vertex, because then you'll know the final coordinate for this person also, because this person's coordinate is known. Then move to this person, like you can find the actual coordinate once you know the coordinate for this person, right? But is there any way to find a definite coordinate? Like you only know that 4 and 5, the like with respect to 4, 5 is 2 units at right and 1 unit at top, like he's 1 unit above 4. But using only these values, you cannot tell what is the coordinate of this, and this, right? So for these 3, your answer will be undefined, and for these 3, you can find your answer using simple DFS. Is this making sense? Yes, no, anything? Is anyone having any doubt? So we can just, like, with all the m pieces of information, we can create an undirected graph, and on that graph we can do a DFS. So finally, if we are able to find answer, like coordinates for a person, we'll print those coordinates. Otherwise, if we have something like this, we'll print undefined. If a vertex or a person is never reached, then we won't be able to find the answer for that person, and we'll print undefined in that case. Is it clear? Yes, no, anything? Okay, why it should be undirected? Like in this case, see, in this case, once from first person, you know that the second person is, let's say, 3 meters to the right, or 3 units to the right and 4 units above. And from third person's perspective, you know that the second person is 2 units back and 1 units down. So from 1, you'll know the coordinates of 2. But now, how will you go from 2? Like you cannot come from 3 to 2. You'll have to go from 2 to 3. So anyway, if from third person's perspective, you know that this person is 2 meters to 2 units to the left and 1 units down, that same holds that from second person's perspective, this person is 1 units above and 2 units right. Using like this information can also be written like this, right? Is it clear? So that's why it's an undirected. So is this thing clear to everyone? Yes, no, anything?
Yes, clear.
Okay. Like anyway, others are not saying anything, so I'm going to assume that like they don't have any doubt in this. So here is the implementation. So first, I'm taking all the values. See, from a person perspective, bth person is x units apart, like x unit from distant away from x-axis, positive x-axis, and y unit distant away from positive axis. So first, since all the inputs, like in input a and b are given to me as one index, I'm decreasing them by 1. Then I'm adding this edge from v, like this simply means from a, b is x, y apart, and from b, a is minus x and minus y apart. Then I'm calling my DFS 0 function, like this is, I'm calling this function. So coming to first to this will have my answer for each person. Initially, everything is minus 118 and minus 118. Why? Because finally I'll know if something is minus 118, it was not reachable. That person was not reachable. So that's why it is undecidable. Otherwise, I can print these two. And how I decided minus 118? See, values of x and y are only up till minus, like they vary between minus 10 to the power 9 and 10 to the power 9. So even if I added all the values, 10 to the power 9 times 10 to the power 5 is something like 10 to the power 14. So these values are never possible. So that's why I have initialized my everything in my answer first as this. Then I have made my answer 0 as this. Why? Because I know for definite, like I definitely know that the first person is at origin. Now I have created a visited this thing. Why? Because in input, it's given that it's possible that we are given something like this. That first person, like from first person, second person is here, and from second person, first person is here. So we shouldn't end up in cycle. Otherwise, we'll get TLE. So that's why I have made this visited cycle, that if a person is visited, I won't again go back to that person. Then I'm calling my DFS for 0th person. I'm marking that person as visited. Then all the neighboring vertices, or all the persons who can, like for which I have information starting from you, I'll mark. If that person has already been visited, I'll continue. Otherwise, I'll calculate the answer for that person, like the coordinates. So what are the coordinates for that person? That is A. This is the x units distant from this uth person. So this A plus the coordinate x coordinate for uth person, and this B plus y coordinate for uth person. Then I'll call this DFS function for V person B. Then finally, for all my answer values, what I'll do, if x is minus 118, I'll print undecidable. Otherwise, I'll print x and y. Is it clear? Okay, what about others? Is this thing clear? Okay. Okay. So let's go to the next problem. So this is the next problem. This problem, we are given that there are n people gathered for an event called flowing noodles. So the people are lined up in a row, numbered from 1 to n, in order from front to back. Now, during the event, the following thing happens m times. So this is going to happen m times. So at time ti, the quantity wi of noodles is flown down. The person at the front of the row gets all of it. Then if no one is in the row, no one gets it. Otherwise, the person who gets it steps out of the row and returns to the original position in the row at the time ti plus si. So a person who returns to the row at time x is considered to be in the row. So okay, this is okay. So after all the m occurrences, we need to report that the total amount of noodles each person has got. So I'll first explain what this problem is. Okay. So assume, see, there are n people and they're standing in a row. So let's say this is the first person, this is the second, this is the third, fourth, all the way up till n. Now assume that in here some noodles are going to flown, and m times the noodles are going to m times the noodles are going to be flown here. So yeah, let's write this again. So assume that there are m people standing, 1, 2, 3, 4 up till n. These are n people standing, and they are standing in this order only, and this is their, like they will always maintain this order. So now assume that on this side some noodles are going to be flown, and m times the noodles are going to be flown. So the first time the noodle is going to be flown is maybe t1, and then other than this we have two other things. So we have w1 and s1. This is the quantity of noodles that are going to be flown. And see, now one is at the front, right? This person. So this person, m times noodles are going to flown. So first time it is t1, w1, and s1. So first time this person gets noodle. So he'll move out of this line, of this order. He's going to come here. And now he has received w1 units of like W1 quantity of noodles, and he's going to come back to this line at the same position after T1 plus S1 time, like at this time. Then maybe after this second, like at this time, W2 noodle, this quantity is flown and this is S2. So now this person gets it. This person will come here. He has received W2 amount quantity of noodles. He or she will return to this line again at T2 plus S2. Maybe at this point, this person will now, like when we have T3, W3 and S3 flown, by that point, maybe this person's time has already finished and he will return to this line. So now, like now we will have something like this. 1 is there, 2 is not there because 2 is here, and 3, 4 like this. So again, this quantity will be received by 1 only. So finally, we have to print what is the total amount or quantity for each person, how much noodles are they going to receive. Is the problem statement clear? Yes, no, anything?
Yes.
So see, this is a very simple problem. What we can do, see, T values are already given to us in sorted order. Like in input, this is guaranteed that the T values that we get are in strict increasing order. So what we can simply do, see, first we have all people 1, 2, 3, 4 in our standing order, right? So let's say, how can we get, what is the smallest value in our collection right now, currently? How we can get it quickly? Which data structure should we use?
Priority queue.
Yes, priority queue or a set. So we insert all of these value in our priority queue or set. Then at each, when we get T, W, and S, we can pick the minimum value from our priority queue. That is the person that is going to get these noodles. And for that person, we can increase the answer for that person. Let's say this is the person with W. And now remove this from this priority queue. And we need another maybe data structure in which we'll hold information like time at which this person will return, comma, this person's number. So this is the first person, second person, third person, right? And this should also store, like this should also have information in increasing order of time. So what we can use here again, if we want these value to be sorted in increasing order of time, but what can we use? Again, we can use a priority or a set, right? For pair values. So before each time, what we can do, we can check this thing, whether there are some values which are already if this time is less than this time, then this person will come back to this order, right? Yes, no, anything?
Yes.
So simply what we can do, after first for each T, W, and S, check in this structure. Okay. Check in this structure if this will have time and P values, time and person. So these are out of your order right now, these person, because they received some noodles and they are standing out of the line. But just check if this person's let's call this return time. So if this person's return time is less than this T, insert this person back in the order and remove this person from this out of order data structure. So, and after then just find what is the minimum value in this. How can you do this? This is just a set or priority queue, right? Just find what is the minimum value, add this to this, add W to its answer, and again remove this from your set or priority queue and insert, like what will you insert in this structure? You will insert T plus S, comma, this person P. Is it clear? So finally, after all these M operations, you will have answer for each and every person. Is it clear?
Yes. Like these 1 to n values, I had taken a Q in the contest. So
Okay.
in what case like it was failing? Like all the things are similar.
No. Q won't actually always work. So where are you inserting? See, let's suppose 3 was removed. Where will you insert 3? At the beginning or at the end?
At the front.
Okay, at the front. What should 3 come before 1? So now you're changing the order, right? order shouldn't get changed. 1 will always come before 3.
Okay, got it.
So I'll show you the implementation. So this is the implementation. I'm first taking TWS as input. Then this is my answer for each and every person, answer vector. So these are the return times. I have made a set of pairs, and this is the set in which I have like all the persons who are standing currently in the order. So now for each value of TW and S, I'm checking if there is some person out of order right now and their return time is less than this time. So I'll insert them back in my order, and I'm going to remove them from return time, this return time set. Then I'm going to check if nobody is standing in the order. I'll simply continue, because in the problem statement, it's mentioned that if no one is standing in the line, nobody will get those noodles. Otherwise, for that person, like this person which is standing at the front, will get these many noodles. And again, I will remove this person from the order, and I'm going to insert that person in this return time set. And now the return time is this thing, and this is the person. Finally, I can print my answer vector. Is it clear? Yes, no, anything? What about others? Is it clear?
Yes.
Okay, so that's it for today. And bye-bye.